Hi, good day everyone. We are Group 9 presenting all of you the topic that we had is plastic and polymers. So, the list of content of our presentation is number 1, history, definition, properties, classification, specification, chemical composition, and lastly, disadvantage and advantages of plastic and polymers. So now let's proceed to the history of the plastic and polymers. It was the mid-80s when the humans began creating synthetic polymers. Um, Synthetic polymers sometimes is a mixture of natural materials like cellulose, but often synthetic polymers use many carbon atoms derived from petroleum and fossil resources. So what is cellulose? Cellulose is a tough, fibrous, water-insoluble polysaccharide plays an integral role in keeping the structure of plant walls to be stable. So let's go in 1839, where Charles Goodyear accidentally discovered a process called vulcanization. So the best example of vulcanization is the wheel car and the rubber band because it has rubber material and more elastic and stronger. So now in 1846, where Charles Schonben, a chemist from Switzerland, discovered a nitrocellulose accidentally while spilling a mixture of nitric acid and sulfuric acid in the cotton. You can see that in a picture in our presentation. So let's go to 1855, where Alexander Parks discovered a celluloid, or commonly called arpacin, which is a mixture of cellulose, nitrate, and camphor lime. Celluloid or packaging is the first thermoplastic that has flexible character when exposed to heat and stiff when it's cold. So the best example of that is the ball in billiard. So now let's proceed in 1869, where the first industrial plastic or synthetic plastic was created by John Wesley. John Wesley, he is the one who challenged with the price of $10,000, which means equivalent to Philippine peso right now, 559,000 and 650 pesos. From a company in New York for everyone who could find alternative materials from ivory. So, what is ivory? Ivory, it is a material that nakukuha siya sa animal mammals. The best example of that is elephant teeth. Because pag kinukuha nila yung elephant teeth dati, nakakagawa kasi sila ng mga materials or kinikirb nila doon sa elephant teeth. Like, for example, is hair comb. Yun yung pinaka-unang atang ginawa nilang suklay dati. So, now, let's go to 1907, where Leo Hendrik Baekeland, a Belgian born in American, created Bakelite, the first synthetic polymer created from a mixture of phenol and formaldehyde. So, here, as you can see in the picture in our presentation, dito na nauso yung mga clock na ang nakapalibot sa kanila is synthetic plastic. Nasanay kasi tayo na ang nakikita dati is wood na nakapalibot sa clock. So, dito sa panahon na to, ginawa na nilang synthetic plastic yung clock cover. And nakagawa rin sila dito ng telephone plastic at etc. So now, let's proceed to 1930, where chemists from DuPont named Wallace Carothers discovered a combination of polymers from adipic acid condensation and certain types of diaminohexane monomers. that could be stretched and formed into a strong threads similar to silk. The best example of it is nylon, because when we touch nylon, we makakapan natin na medyo madulas siya, parang katulad ng silk, and hindi rin siya basta-basta nasisira dahil nga meron itong stretch and form materials na threads. So now, let's define what is plastic and polymer. So, plastic is originally referred to a material that was flexible and easily formed. So, early in the 80s, the word plastic change to represent polymetric materials. So, like what I said earlier, plastic is pliable and easily shaped. It only recently became a name of a category that called polymer. So the word for polymer is made up of many parts or many molecule change. So natural polymers can be found in nature. For example of that is cellulose. Cellulose is the material that makes up the cell walls of plants. It is a very common natural polymer.
Properties of plastic. So, there are 4 properties of plastic. First is strong and tactile. So, alam po natin na ang plastic po is mabilis po siyang ma-deform, lalo na po pag na-expose po siya sa heat. And ang pangalawa po is poor conductor of electricity and heat. So, alam po natin na electric charges cannot be carried if there is no free electrons. So, ang plastic po has a few and or no free electrons. So, it means ang plastic po is poor conductor ng electricity. For the third one po is easily molded into different sizes and shapes. So, katulad po nung una, yung plastic po is mabilis po siyang matunaw o ma-deform pag po na expose po siya sa heat. And yung consistency po kasi talaga ng plastic is flexible po siya, and kahit anong gawin mong sizes pwede po. And pang-apat po is resist corrosion and resistant to many chemicals. So it means hindi po lahat ng plastic is mabilis po ma-deform. Katulad po ng high density polyethylene, good chemical resistance and corrosion resistance po siya. Tulad din po ng halar, nare-resist po niya yung chemicals such as acid and solvents.
Good day everyone, I'm Christian Justin Borillo from BSA 1B. Today I will discuss to you some importance of polymers. Heat capacity or heat conductivity is the extent to which the plastic or polymer acts an effective insulator against the flow of heat. This means of the stiffness of molecules decide whether a polymer is a good conductor of heat. Thermal expansion. This property is the extent to which a polymer expands or contracts when subjected to heat and cold is measured. Crystallinity. This property is based on the type of arrangement of polymeric chains. Polymers with less crystallinity are more useful as they are brittle. Permeability is the tendency of a polymer to pass extraneous materials. For example, polyethylene is used to wrap foods because it is 4,000 times less permeable to oxygen than polystyrene. Elastic modulus. It is the force it takes to stretch the plastic in one direction. Tensile strength is the strength of the plastic, so when getting the tensile strength, the force that must be applied in one direction to stretch the plastic until it breaks. Resilience. It is the ability of the plastic to resist abrasion and wear. Refractive index is the extent to which the light bends as it passes, the polymer is measured as its refractive index. Polymers used to property in spectroscopy. Resistance to electric current means that most of the polymers are bad conductors of electricity. Nowadays, conductive polymers are used in semiconductor devices. Their conductivity arises due to conjugated carbon double bonds, and also there is a growing interest in conducting polymers, which can be charged and discharged, and conducting polymers that can pick up an electric charge when exposed to light.
So next po, I'm Rafael Jan B. Pumida, and the next topic is about the classifications and specifications of plastics. So plastics po ay maraming mga klase. Kapag pinag-usapan po natin kung ilan po lahat ng klase ng plastics, ay aabot po tayo sa hundreds and thousands. So ganun po karami. So, meron po akong binigay dito ng mga categories na most common na ginagamit. So, plastic makers tend to group plastics into two general classes, the thermoplastics and the thermosets. So, thermoplastics or thermosoft plastic is any plastic polymer material that becomes pliable or moldable at a certain elevated temperature and solidifies upon cooling. So, can be rebelted and essentially returned to their original state. So, essentially po, kapag halimbawa ininit mo yung plastic tsaka matutunaw, kapag na lumamig yun, babalik siya sa kanyang original state. Ayun po yung mga thermoplastics. So, thermoplastics include plastics you're likely familiar with. So, ito po yung polyethylene, polypropylene, polyvinyl chloride, polystyrene, nylon, polycarbonate, and others. So, next po, the thermosets. Material especially synthetic plastic or resin that hardens permanently after one application of heat and pressure. Thermosets they cannot be returned to their original state. So essentially po, opposite po siya ng mga thermoplastics. Ang thermosets po ay kapag ininit mo po yung thermosets ay hindi na siya babalik sa kanyang original state. So thermosets include vulcanized synthetic rubber, acrylics, polyurethanes, melamine, silicone, epoxies, and others. So next, there are other categories of plastics. So isa na po yun yung engineering plastics. Engineering plastics are a group of plastic materials that have better mechanical and or thermal properties than the more widely used commodity plastics. So sa engineering plastics po, dinidesign po yung mga plastic na yun para maging super fire resistant siya. So ibig sabihin po, yung mga properties niya po ay super specialized na kaya niyang mag-resist ng mga sobrang taas na temperature. Halimbawa lang po. Next is the plastic fibers. Plastic fibers are plastics that have been spun into fibers or filaments and used to make fabrics, string, ropes, and cables, even optical fibers. So sa plastic fibers po, yung pinakamagandang example din yung optical fibers na ginagamit sa mga wires para mas mabilis na mag-transmit ng information. So next is the elastomers. Elastomers are any rubbery material composed of long chain-like molecules or polymers that are capable of recovering their original shape after being stretched to great extents. So, ang elastomers po, galing po sa pangalan na elastomers. Makukuha po dyan yung elastic. So, ibig sabihin po nababanat. Example po dyan yung mga goma po, yung nababanat. So, yun po. So, next po, dito po sa picture, makikita po natin mga triangle po na may tatlong arrow na interconnected. So, ang tawag po dyan sa symbol na yan ay Mobius loop, na ibig sabihin po, pag meron po yan sa isang bagay ay pwede po siyang i-recycle. So, meron po dyan 7 na numbers. So, sa 7 na numbers po ay iba-ibang klase din ng plastic. So, sa number 1, PET, na ibig sabihin ay polyethylene terephthalate. So, PET po is commonly used in commercially sold water bottles, soft drink bottles, sports drink bottles, and condiment bottles. So, si PET po yun yung pinaka-commonly used. So, pag tinignan mo po yung isang mineral bottle, sa ilalim po ay karaniwang merong symbol po na triangle, tapos may 1, tapos PET. So, next, sa 02, PE-HD, na ibig sabihin ay polyethylene and high density. So, sa HDPE po, is commonly used in milk and juice bottles, detergent bottles, shampoo bottles, grocery bags, cereal box liners. So, yun po yung mga example niya. Sa number 3 po, sa type 3, PVC, polyvinyl chloride. So, sa PVC po, yun po yung mga ginagamit na plastic sa mga tubo, sa mga pipes. Can be flexible or rigid and is used for plumbing pipes, beer, food packaging, shrink wrap, plastic children's toys, tablecloths, vinyl flooring, children's playmats, and blister packs. So, sa number 4, PELD, polyethylene low density. So, sa number 4 po, low density, tas sa number 2, high density. Sa LDPE is used for dry cleaning bags, bread bags, newspaper bags, reduce bags, and garbage bags, as well as paper made cartons and hot or cold beverage cups. So next, number 5 ay type 5, polypropylene. Polypropylene is used to make yogurt containers, deli food containers, furniture, luggage, and winter clothing insulation. So yun po yung mga example niya. Next is the type 6, PS, or the polystyrene. Is also popularly known as styrofoam. So, styrofoam po yung pinaka-common na plastic, ay isa sa mga pinaka-common na plastic na ginagamit sa mga styro cup, yung ginagamit sa mga noodles. Yun po yung mga sa mga handaan na styrofoam. So, sa type 7, o bisphenol A and others. So, sa type 7 po, yun po yung mga pinagsama-sama na hindi kasama sa 6 na nauna. So, dito po siya nasasama. Is any plastic item not made from the above 6 plastics is lumped together as a number 7 plastics. So, things like CDs, baby bottles, and headlight lamps. So, yun po ang example niya. So, yun lang po. Salamat.
I'm gonna report the classification of polymers. First is based on chemical structure. Under the chemical structure, there are two, which are homopolymer and copolymer. Homopolymer is a polymer that is made from identical monomer. while the copolymer is a polymer that is made from more than type of monomer. As you can see on the diagram, um, homopolymer is um, homopolymers are identical monomers, while the copolymers is there are um, one or two types of polymer. Next is based on structure. Under the based on structure, there are three types, which are line polymers, branch chain polymers, and cross-link polymers. In linear polymers, the repeated units are joined together and end-to-end in single chains. Um, in branch polymers, which is side branch chains are connected to the main ones. And then the last is the cross-link polymer. The adjacent line chains are joined one to another at various positions by covalent bond. Next, based on molecular structure, there are two classifications of molecular structure. These are thermal behavior and intermolecular structure. Um, Under thermal behavior, there are two types of it, um, which are thermoplastics and thermosets. Thermoplastics are no cross-link between the change and it thus softens when heated, while thermosets have strong covalent bonds between the polymer chains, which increases the cross-link density and it it is resistant to heat. And under the intermolecular, there are two types also, which are elastomers and fibers. In elastomers, are held together by weakest van der Waals forces among their molecules. That's why they are stretchable. While in fibers, are held together by strong intermolecular forces like hydrogen bonding or dipole-dipole interaction. Next is based on mode of polymerization. There are two. The addition polymers is formed when double bonds are broken in individual molecule, and these rebond to another molecules so that long chains are formed. Example is yung polythene. Then the condensation polymer is formed when molecules are joined together with elimination of some other compound, usually water. Ang example nito are nylon and polyester. Last, based on tacticity. Tacticity is the orientation of monomer units in the polymer molecules with respect to the main change. Under the tacticity, there are three types of it, which are isostatic polymer, symbiotic polymer, and atatic polymer. Isostatic polymer is the type of polymer in which the characteristic groups are arranged on the same side of the main chain, as you can see on the picture. Symbioactive polymer, the side groups are arranged in alternative fashion. And the last is active polymer, the alternate group are arranged in irregular fashion. It has a proper strength and more elasticity.
Polymer is came from Greek word poly, which means many, and mer, which means number or unit. Polymer is molecules made from many repeat units that is composed of very large molecules called macromolecules, which are multiples of simpler chemical units called monomers. The macromolecules is a big long chain molecules that has a high molecular weight, while the monomers is chemically joined together to form long chain, and it has a weak
hydrogen bond. To form polymer, we need to go on process which is called polymerization. There are two types of polymer, which is the natural and the synthetic polymer. The natural is secure in nature and can be extracted. These examples are silk, wool, and cotton. Additional information. The strongest natural polymer is the spider web, while the weakest is the natural rubber. The synthetic polymer is derived from petroleum oil that made by scientists and engineers. Synthetic polymers examples are PET bottles, PE film, and PP granules. We use polymer in construction industry because of their ability to produce long-lasting, energy-efficient, and cost-effective building materials and structures. The examples of polymer that used in construction are wall panels, roofing materials, piping system, seal, and coatings.
Chemical composition of plastic. So there are 6 chemical composition of plastic such as carbon, hydrogen, oxygen, nitrogen, chlorine, and sulfur.
We are the chemical composition of polymers. First, silicon, oxygen, nitrogen, carbon, then lastly, glucose.
Hello everyone, this is advantages and disadvantages of plastics. Plastic advantages: there are excellent electrical properties, light and strong, excellent chemical resistance, suitable for mass production, non-toxic in general. For disadvantages, subject to heat deformation, soft surface results in scratches, poor mechanical strength, difficult disposal after use.
So now let's move on to the advantages of using polymers. The first one is it is cheap to make. Most widely used polymers are talagang mura kumpara sa ibang materials na serving the same purpose. Next is many uses because of their different properties. There are probably 100 different polymers in use today dahil maraming pwedeng gawin dito. Compare that to the number of metals, not metal alloys, polymers can be and are alloyed too. Next, provide jumps in firms which make the polymers and the product. The next one is some polymers can be recycled, melted down, and made into something else, which saves valuable natural resources. Lahat ng thermoplastics are recyclable during manufacture to such an extent that there is no scrap, and all plastics can be recycled into hydrocarbons to produce energy, fuel, and raw material for new plastics. Pero yung idea of recycling plastics from garbage is like recycling salads from garbage. Most people would not buy a salad knowing it came from a garbage. Next is, if polymers are used instead of wood, fewer trees will have to be cut down. Dahil nga sa gawa ito sa plastic, mas malilesen yung paggamit ng mga woods na magbubunga ng hindi pagputol ng mga puno. Now let's move on to the disadvantages of using polymers. The first one is people do not like to live near polymer producing industrial works. Dahil yung plastic in electronic waste or e-waste have become a serious global environmental and public health concern due to its large production volume and the presence of inadequate management policies in several countries. Next, some people think plastic products look cheap compared with natural materials. At dahil nga para sa mga nakararami, mukhang mura yung plastic, kaya din nila ito pinipili. Next, made from oil, a non-renewable resource. Oil, also known as petroleum, is a fossil fuel. That means it made from the remains of very old living organisms such as algae, bacteria, and plants. To make plastic, refiners heat the propylene together with the catalyst, a substance that speeds up chemical reactions. This causes individual molecules of propylene to look together like beans on the string. Next, most plastics are not biodegradable, so there is a problem of how to get rid of them. At dahil nga yung iba hindi biodegradable, nagre-result ito sa pag-release ng harmful chemicals into soil and water, or break into tiny bits that animals, fish, and birds eat. Next, landfill sites are ugly. Understood naman kung bakit di ganon kaaya-aya yung mga landfill sites, lalo na dito sa Pinas. Next is give off toxic fumes when they burn. Yung polymers kasi, meron siyang several toxic constituents like phthalates, polyfluorinated chemicals, bisphenol A or BPA, brominated flame retardants, and antimony trioxide, which can leach out to have a adverse effect on environmental and public health. The last one is sorting types of polymers for recycling can be expensive. Di porket sinabing recyclable, makakamura ka. May ibang types ng polymers na mahal ang pagpaparecycle.